You're watching a video about my Cloggers Knife manufacturing process, as well as its various applications at my log cabin camp. I partially forged and partially welded my Cloggers Knife from a rail clip and a leaf spring. This knife's shape is based on traditional design. Using Cloggers knives, shoemakers would shape a wooden sole and outer contours of wooden shoes. This excellent tool is ideal when it is necessary to shave off a large chunk of wooden plank without using an axe. This is because the plank might not withstand an axe impact and split, or you just might need to make repetitive high-precision cuts. You may have noticed that my knife has some differences from traditional ones. The fact is that a traditional Cloggers knife is equipped with one of two types of cantilever mounting attachments, which allow the workman to exert great forces on the knife's cutting edge when required. Either a hook that is engaged into an eye in the workbench, or a pin that is inserted into a hole at the desired height from the base block. Both mounting methods have obvious advantages and equally obvious disadvantages. Because I've never held a Cloggers knife in my hands until I forged one, I couldn't speculatively choose which mounting method would work better for me. As a result, I decided to combine both mounting designs in my Cloggers knife to later decide which one works best. Despite the considerable length of the knife's cutting edge, it is not difficult to resharpen it even in field conditions. I used the metal tri-square and some wet, dry sandpaper. It is not at all necessary to build a water-powered grinding wheel in the woods. When I decided to forge my Cloggers knife, I assumed that I would use it rarely, but looking back at the past 2 years of owning the exotic tool, I was surprised to find that I use it whenever it is in reach, and it's been on my tool rack for the past 2 seasons. So I came to the conclusion that the Cloggers knife is more of a universal tool than a specialized one. Well, at least in my case, as I use it whenever I need to finish the end of a workpiece, to slice wood chips, to cut wedges, to sharpen pegs, and so on. If you followed my channel, you may have noticed that I've used the Cloggers knife in every woodworking, carpentry, agricultural project, and oddly enough, in half of my culinary experiments. In order to support my claim, I will show a couple of memorable examples of its use. In this footage, I just chamfered the butt end of my two-handed pestle made from dry maple. As a side note, it is advisable to refresh a pestle's working surface regularly. Firstly, the pestle's edges get damaged during use, and secondly, after crushing coffee beans, the coffee powder gets packed into the wood's pores, so when you later grind wheat, for example, it is a good idea to get rid of the coffee smell. Or, if you grind pepper in a mortar, then you most likely do not want to mix the aroma of spices and coffee. I remember when I baked an apple pie in my earth oven. I even cut apples with the Cloggers knife, but right over the sake of mischief. It is not a kitchen knife after all. At any rate, it was arguably the best apple pie in my life. The Cloggers knife also excelled at finishing the crosscuts of the armrest hexagonal supports of my bushcraft chair. I don't even know what hand tool would work better for the task. Sanding or planing would take longer and wouldn't leave such a glossy surface. Without the Cloggers knife, I would almost certainly have left the crosscut as is. However, it is precisely such small details that give an appeal to handcrafted furniture. You might remember, together with a beaver, I built a creek dam at my log cabin camp. To be more exact, I only laid down the foundation and installed the drain pipe, while the beaver did the rest of the work during my absence. In dry summers, the creek almost dries out, but beavers value and save water. So my Cloggers knife helped me in this project as well. I used it to feed the wooden plug to the drain pipe, to drain accumulated pond water when needed. And of course, I used my Cloggers knife for making various kitchen utensils, such as this scoop that I carved from a block of black alder. For some reason, when I published this footage on my Instagram, most people unanimously claimed I was slicing cheese. Take a closer look. It's a block of laundry soap that I used in my water wheel-powered washing machine. In any case, This trusty tool proves its multi-purpose functionality by even helping me make bushcraft laundry detergent. Soap slices dissolve in water much faster. I want to believe that after 5 long minutes of my Cloggers Knife demonstration, I was able to convince my audience that the Cloggers Knife is an undeservedly forgotten tool and you might want to make one for yourself. So it's time to move on to the story about its creation. It all started with a leaf spring I got from my friend and a rusty railway clip that I found on the ground. I decided that the clip would make a good stiff handle and a mounting attachment, while the leaf spring would become the knife's blade. As a first step, I removed the remnants of the former attachment by drilling out a rivet and freed the spring from years of corrosion. Then I straightened the spring rocker by heating it up in my forge, placing it on the anvil's face and giving it a couple of hammer blows. Although wait, let's go back 5 hours. We need a good sized forge for the project, and I haven't said a word about it yet. You might remember how I made my first mini forge from a tin can, plaster sand mix and a blowtorch, and then a second larger forge made from a small tin barrel powered by propane too. I also assembled a coal forge from 2 buckets, some sand, a cast iron roaster pan and an old fan. But this time I need a really large gas forge that could be assembled fast. It only took me an hour to complete it. After my house construction, I had some leftover hollow bricks that I used for this forge assembly, just like a stack of kids' toy blocks. The blowtorch was borrowed from my old tin barrel forge. For insulation, I used a kaolin fiber felt that costs pennies. All in all, such brick forge is low budget and can be quickly assembled. Best of all, you can quickly change its inner chamber's dimension as needed. Now, when half of the workpiece can fit in the forge, it can be heated and straightened. Only half of the leaf spring will be used for the Cloggers Knife blade. The rest of it became a large draw knife later. If I were a blacksmith, I would have chopped the heated workpiece with a chisel. But at that time, I did not have the right tool or knowledge, so I just sawed it off with a side grinder. Next time, I will do it the traditional way. Look at the layout markings. At first, I planned to lighten the blade in the area of the lever mount, but in the process, I abandoned this idea. I decided that the stiffness of a Cloggers Knife is more important than its weight and the delicate beauty of the tool. Now I'm dividing the railroad clip into 3 parts. I used the central part as a mounting pin, the pivoting point of the future Cloggers Knife. As for the larger piece, I forged a tapered punch tool from it. Because the railroad clip is made from a spring structural steel grade 60S2A, it's not that easy to straighten it. This is why I had to make a blacksmith bending fork for this task. So I got sidetracked again for making another auxiliary tool. Of course, it is a loss of pace, but on the other hand, a bending fork is an incredibly useful tool around the metal shop. The working part of the fork is made from a large leaf spring, and I probably should have annealed it first, but I figured I could drill 4 holes in the spring steel and my angle grinder's attachments could handle the hardened steel. Well, I did it, but it took longer than expected. Taking advantage of the fact that the following actions are self-evident and self-explanatory, I want to ask you, considering that I'm only a novice, do you think I will succeed in making Cloggers Knife on my first try? I think the most experienced and insightful have already guessed. Well, while I distracted you from the making process with idle talk, my heavy-duty bending fork got completed and is now ready for use. So it is a high time to heat up the spring clip in the forge and then to start its sequential straightening. And of course, I failed in straightening the spring clip on the first try, but the skill comes with experience. Now, 2 years later, I unbent such a spring clip in 2 heating cycles in a way that further straightening is almost not necessary. It took me at least 5 heating cycles and a lot of hammering to get the rod straight on the first try. Luckily, it was not necessary to preserve the cylindricity of the rod in this project. But after swinging a heavy mallet for a while and looking at the dent marks left by it on the rod, I decided that I needed a special backing device, a exclusively for straightening a rod, and a year later I assembled such a tool. If you know its English name, please let me know below. At any rate, it is a completely different story, and this device did not take part in the Cloggers Knife manufacturing process. After fitting the parts together, the blade, the handle and the hinge, I decided to reinforce the blade's spine. To do this, I used the same rod, which is made of the same spring steel grade 60S2A as the blade. I hot forged the rod into a strip using a blacksmithing hammer with a hemispherical striker. After half an hour of forging, I envied ambidextrous people as my right hand insistently began to demand a break. But I'm right-handed, otherwise I would have changed my hand and continued this exciting CrossFit exercise. Note that the forge is outside and the anvil is in the shop. Such setup has a number of advantages. Obviously, this is safer, less noisy, and most importantly, all combustion products remain outside, and I breathe relatively clean air without using an exhaust hood, plus I don't have to worry about the weather. After a break, I decided that I would definitely assemble a mechanical hammer for my blacksmith shop, and most likely it will be wooden. It should be an interesting project. Remember, earlier in the video I said that my Cloggers knife will have two alternative mounting options. This means that the knife must be equipped with a pivoting hole. I decided to use a drift to punch it, as the hole's diameter will be larger than the width of the strip itself. Additionally, I had to make a special cylindrical drift to be able to enlarge the hole to the desired diameter. Later, this 70mm, almost 11/16 inch drift was used as a metal pin for this knife's mounting. Additionally, this hardened tip drift came in handy around the blacksmith shop more than once. I used it as a punch, as a nail setter, as well as an engineer's scriber. In order for the hole to look more aesthetically pleasing, I countersunk its chamfers using an engine valve. The excess part of the punched rod could be sawed off with an angle grinder, but this time I decided to do it the right way using a hot cut hardy. I could make it fast since the parts for this blacksmithing device have long been in my shop. The advantages of this cutting method are having less dust in the air, less noise, and no angle grinder disc waste. Besides, learning a new skill is always beneficial. The handle part that I attached to the blade and then to the mounting hole could now be welded together, after which all of the bumps and irregularities formed during forging and welding can be ground off. Because there was a small defect on the blade's portion of the metal strip, I simply added some material with a welder there, which predictably curved the metal strip, and I had to flatten it on the anvil. The handle portion of the knife's spine should be slightly humped. Ergonomically, the point of a force application, which is going to be the grip portion of the tool's handle, should be on the line of the blade's cutting edge and the knife's mounting point. Otherwise, it will be twisting out of your hand during use. To properly align the knife's parts, I slightly bent the handle in a fishtail shape. By the way, a simple forge for zone heating of a metal rod can be assembled simply by folding a flap of kaolin fiber felt or any other fire-resistant felt. All of the Cloggers knife's parts are ready, which means it is time to weld them together. I have little experience in welding, and these were my first steps in working with a semi-automatic welding machine. However, I can say that this method is certainly more convenient than stick welding. Working with metal is like working with clay. If there is not enough, you can simply add some clay. If there is an excess, you can remove it. You cannot do it when you are carving stone or wood. Of course, the swivel mount should be given extra attention. After all, this is where the maximum loads will be exerted on during the Cloggers knife's operation. Given the length of the lever and my weight, the stresses here may well exceed a ton per square centimeter. Taking into account that the deformation sigma for C45 grade steel is about 5 tons per square centimeter, the maximum design load of this part is only 5 times greater than the experimental one. It is here where the weld seam should be of the highest quality and reliability. The blade's back reinforcement was also welded. However, I did not dare to apply continuous weld seam, thinking that due to my inexperience, the blade's spine might expand and curve. Therefore, I spot welded the back support, alternating the blade's sides. In the process of electric arc welding, the knife's internal stresses accumulate, but most of them can be removed by normalizing the workpiece in the forge. So before hardening, I straightened the blade once again, and only then proceeded to its final hardening. I decided to heat the blade's cutting edge and then immerse it in water, so it would be a zone hardening procedure followed by self-normalizing. The plan succeeded. I briefly placed the knife in the forge, and since the blade's spine is thicker and more massive than its cutting edge, it did not have time to really heat up, and when immersed in water, thus only the cutting edge would harden. I should have stopped right there, even though the blade's cutting edge slightly curved at that point. This is when I made a fatal mistake. As you know, the best is the enemy of the good, and the bad head does not give rest to the legs. As if in order to prove these popular sayings, I decided to straighten the blade and then temper it again, using the traditional differential hardening method this time. I cannot rationally explain my further actions. It is completely incomprehensible what I was counting on. Literally, last year I ruined a draw knife's blade in exactly the same way. Instead of relying on a self-normalizing phase, I stubbornly continued to cool the cutting edge in water. As Lewis Carroll wrote in Alice's Adventure in Wonderland, if you drink much from a bottle marked poison, it is certain to disagree with you sooner or later. It is obvious that if a heated steel plate's side is cooled for a long time, the internal stresses will increase, and the cooled side will gain hardness and brittleness, resulting in its cracking with the very unpleasant sound of a complete fiasco. In other circumstances, I would have just put the cracked workpiece aside with a smile, took the second half of the leaf spring, and repeated all the steps, only with due diligence this time. However, it was late in the evening, and tomorrow morning I was leaving for my log cabin camp for a month, where I planned to use this tool in my new projects. And after bargaining with my internal quality control center, I decided to do a temporary fix. Temporary. They say there is nothing more permanent than temporary anyways. So I chamfered the crack's edges using an angle grinder and simply welded the crack. Obviously, the knife's hardness suffered in the area of the weld, but I decided not to reharden the blade because, firstly, there was simply no time, and secondly, most of the knife's cutting edge is still very hard, while the blade's internal stress has been unintentionally eliminated by my radically barbaric method. All things considered, the final result isn't that bad. The knife is safe now, and it won't burst during operation, and it will stay sharp. So what remains is to grind the welds, sharpen the blade, and shape the geometry of the handle. I shaped the handle's tang to accept a traditional wooden handle. The knife's tang should be rectangular, slightly tapered, and bent up. In this case, with each cut, the operator will press the wooden handle more strongly onto the tang, so the wooden handle will not dangle or fall off even without additional fixation. The first year, I used the Cloggers knife without a wooden handle, which was a mistake. The maple handle significantly improved the maximum exertable force and the blade's control. Maple is the hardest wood I could find around here. Despite the fact that during the tool's transportation I knock off the wooden handle from the tang, it has not cracked or falling off during use. Again, I did not use any glue. I just drilled a hole in a wooden block and hammered the maple handle onto the tang with a wooden mallet. Simple and reliable. As you understand, a Cloggers knife always goes together with a specialized support block equipped with a cantilever mount. I installed such mounts on my shaving horse, on my topsy-turvy workbench, and on sawhorses that are back home. Later, I even made a specialized mounting stand for the Cloggers Knife. At the very beginning of the video, I said that I planned to choose one of the two types of cantilever mounting methods based on the results of field tests. Even though the field trials lasted for 2 years, I haven't made my choice yet. Both mounting methods are good and they don't even get in the way of each other. 2 years ago, I didn't have time to build this specialized Cloggers Knife stand and only managed to finish it last summer. I have not yet come up with a name for it and I'm waiting for your suggestions. Perhaps you can come up with an original name because I'm at my wit's end. A few words about the non-obvious value of the Cloggers Knife. While shaping a workpiece with such a tool, I noticed that I never get tired. A large amount of material is removed by mostly using a body weight and a lever principle. Also, a change of activity can be restful because when you work using fundamentally different tools, you load different muscle groups. Therefore, you increase your productivity and almost never get tired. For example, I could have shaped this workpiece using my primitive pole lathe, but then I would have spent more time and effort. I believe that any work, including physical work, should be enjoyable. Thus, making this Cloggers Knife helped me to take a break from my office work routine, brought aesthetic pleasure, as well as filled my blacksmithing skills gaps. In any case, based on the experience of using this knife for different projects, I can say that I do not regret the time spent on making it. When I gain more experience in blacksmithing, I will make another Cloggers Knife, this time on a more professional level, I hope. Friends, I'm pleased that you watched this video to the very end, which means you found the video interesting, perhaps even helpful, and the many hours spent to shoot and edit it were not wasted. You may have noticed I do not publish my videos often, and even if you're subscribed to the channel, you most likely will not receive notification about a new video, but you can try to set up a bell for all notifications. They say it helps. Thank you for sharing my videos with your friends, and let good people watch good videos. This is Max Igorov, St. Petersburg, Russia. P.S. Below I left a link to my DIY projects playlist, as well as playlists about my log cabin building, bushcraft projects, kayaks making, and outdoor cooking. I hope to see you back on Advoko Makes.